Desde la Universidad Militar Nueva Granada, en Bogotá, Colombia, transmite UMNG Radio. UMNG Radio. Una emisora alternativa, cultural e independiente. Desde la Universidad Militar Nueva Granada. Esta es UMNG Radio.
Tune in and speak up. Hello, English learners. Want to learn something interesting whilst having fun? Welcome to Tune In and Speak Up, the podcast where you'll get to know this beautiful language in depth. Each week, we'll dive into exciting topics, share practical tips, and tell you fascinating English language stories. So whether you're studying, going to work, or just relaxing, connect, listen, and let's make English part of your world. Wherever you are, whenever you want, just hit play, tune in and listen up. Tune in to UMNG Radio every Tuesday from 11 a.m. till noon. Don't just learn English, live it.
Okay, good morning, everybody. Welcome to Tune In and Speak Up, the podcast from Universidad Militar Nueva Granada, where we explore curious stories, surprising facts, and cultural insights from around the world, all through the lens of English learning. This is the podcast where unusual moments from history and culture become your classroom for practicing English. I'm Jorge Bermudez, teacher of English at the Department of Multicultural Studies at UMNG, part of the School of Education and Humanities. I'll be your guide through some of the most unexpected and thought-provoking topics, from forgotten inventions and everyday objects to strange ideas that quietly changed the way we live. Whether you're learning English as a second language or simply enjoy discovering how culture and history shape our daily lives, this podcast is for you. So if you're ready to improve your listening skills, expand your vocabulary, and explore the hidden stories behind ordinary things, grab your headphones, tune in, and let's speak up. Today, we're going to answer a very interesting question. Why do clocks run clockwise? Okay, now to begin with, let's say that clockwise means the movement to the right, the circular movement to the right, present in every clock. Okay, so we're going to be clarifying that vocabulary. Clockwise to the right and counterclockwise to the left. Okay, let's begin with the introduction, the direction of time. Time surrounds us. It wakes us up in the morning, tells us when to work, when to eat, and when to sleep. We organize our lives around it so completely that we rarely stop to think about how time is shown to us, or why it looks the way it does. Everywhere in the world, clocks look surprisingly similar. They are round or rectangular. They are divided into hours and minutes. And most importantly, their hands move in the same direction. From the number 1 to the number 12, from left to right, in a smooth circular motion. This movement feels natural. It feels correct. It feels so obvious that questioning it almost seems pointless. But this raises a quiet and fascinating mystery. The direction of the clock is not required by physics. It is not demanded by mathematics. And it is not the only possible way to represent time. Yet, for centuries, humanity has agreed on this single direction. Why? To understand the answer, we have to forget modern life for a moment. We must imagine a world without electricity, without screens, and without machines that measure seconds with perfect precision. We must return to a time when the sky itself was the clock. Long before clocks ticked, rang, or glowed, people watched the movement of the sun. Day and night were the first units of time. Shadows were the first indicators of passing hours. Human beings learned to read time not from devices, but from nature. This is where the story of Clockwise begins. The modern clock is not just a machine, it is a historical document. Its direction tells a story about geography, tradition, and human habit. A story that begins thousands of years ago and continues silently every time we check the time. Today, we live in a digital world. Phones and computers show time with numbers, not hands. Yet, even digital timekeeping is influenced by the old circular clock. Progress bars, like the ones we have in the picture, move in the same direction. Loading symbols rotate the same way. The idea of forward still follows the path established long before digital technology existed. This tells us something important. Human conventions are powerful. Once a system becomes familiar, it becomes invisible. We stop noticing it, and eventually, we stop questioning it. Clockwise is one of those invisible conventions. But like all conventions, it has an origin. This episode explores how a simple natural phenomenon, the movement of a shadow, became a global standard that defines how billions of people understand time. It is a story shaped by the Northern Hemisphere, by medieval engineers, and by the human need for consistency. It is also a reminder that what feels universal is often local in origin. The direction of time on a clock face is not written into the universe. It is written into history and human society. In the following segments, we will trace this story step by step, from ancient sundials to early mechanical clocks, from sunlight and shadows to gears and mechanisms, from practical decisions to cultural habits. By the end of this episode, the clock on your wall will look the same, but it will no longer feel the same. Because once you understand why clocks run clockwise, you begin to see time not just as something that moves forward, but as something humans have carefully designed, agreed upon, and passed down across centuries. And it all starts with a shadow. This takes us to our first segment. Look at this picture. When the sun was the clock. Before humans invented clocks, time did not tick. It moved silently, following the rhythm of nature. Days began with sunrise and ended with sunset. Seasons changed slowly, marked by temperature, plants, and the position of the sun in the sky. For thousands of years, this was enough. But as societies grew more complex, people needed more precise ways to organize daily life. Farmers needed to know when to work the land. Religious communities needed fixed moments for prayer. Cities needed shared schedules. The solution did not come from machines. It came from observation. One of the earliest and most important tools for measuring time was the sundial. Here in the picture, we can see a sundial. This is one of the simplest scientific instruments ever created. It usually consists of a flat surface, the round rock, and a vertical object placed in the center. This object, often a stick or a metal piece, is called a gnomon. When sunlight hits the gnomon, it creates a shadow, as we can see in the picture. As the sun moves across the sky, the shadow moves too. This movement is predictable. It repeats every day. And most importantly, it creates a visible path that humans can follow. This was humanity's first clock phase. Ancient civilizations all over the world used sundials. They appeared in ancient Egypt, Mesopotamia, Greece, China, and Rome. Although designs varied, the basic principle was always the same. The position of the shadow showed the time of the day. What many people do not realize is that the direction of the shadow's movement depends on where you are on Earth. In the northern hemisphere, where much of early European civilization developed, the sun rises in the east, moves across the southern part of the sky, and sets in the west. As a result, the shadow on a properly aligned sundial moves from left to right during the day. This left to right movement became familiar. It felt natural. People learned to associate it with the passing of time. No one decided this direction in a meeting. No one voted on it. It was simply observed day after day. Over time, sundial makers began marking hours on the stone or metal surfaces. These markings followed the path of the shadow. The morning hours appeared on one side, the afternoon hours on the other. The sun, through its shadow, was silently teaching humans how time should move. This is a crucial moment in the story, because once a pattern becomes familiar, it becomes expected. When later generations thought about time passing, they imagined it moving in the same direction they had always seen on sundials. The concept of time already had a direction long before any gears existed. It is important to note that this experience was not universal. In the southern hemisphere, the sun appears to move across the northern part of the sky. On a sundial there, the shadow moves in the opposite direction. If early clock-making traditions had developed mainly in those regions, the global standard for time might look very different today. But history followed a different path. Mechanical clocks did not appear first in Africa, South America, or Australia. They emerged in medieval Europe, where sundials had already established a familiar direction for time. So when humans eventually tried to replace shadows with machines, they did not start from zero. They copied what they already understood. The shadow had already drawn the map, and the machines would follow it. This takes us to our second segment, from shadows to gears. By the late Middle Ages, European societies were changing rapidly. Cities were growing, trade was expanding. Religious life followed strict daily schedules. Monasteries, in particular, required accurate timekeeping to organize prayers, work, and rest. Sundials, while useful, had one major limitation. They only worked when the sun was visible. Clouds, rain, and darkness made shadows unreliable. This problem pushed craftsmen and engineers to search for a new solution, one that could measure time independently of daylight. The answer was the mechanical clock. The earliest mechanical clocks appeared in Europe around the late 13th and early 14th centuries. These early machines were large, heavy, and far from precise. They often lost or gained time. But they had one revolutionary feature. They could run continuously, day and night. Inside these clocks were gears, weights, and an escapement mechanism that controlled movement. Instead of following the sun, time was now controlled by metal and gravity. However, when clockmakers designed these new machines, they faced an important decision. Which way should the hands move? The answer was not debated for long. Clockmakers simply copied what people already knew. The circular movement of the hands followed the same direction as the shadow on a sundial in the northern hemisphere. This made the new clocks easy to read and familiar, even though the technology behind them was completely new. The machines imitated nature. This choice created a powerful connection between old and new forms of timekeeping. Even though mechanical clocks no longer depended on the sun, they still respected the direction that the sun had taught people. As mechanical clocks spread across Europe, they were installed in churches, town halls, and public squares. Large clock faces were placed high on buildings so that everyone in the city could see them. For many people, these public clocks were the first experience with mechanical time. And everywhere they appeared, the hands moved in the same direction. Little by little, this movement stopped being associated with sundials. It became associated with time itself. This is when the idea of clockwise was born, not as a scientific term, but as a shared visual experience. Over time, clock mechanisms became smaller and more accurate. By the 16th and 17th centuries, clocks were no longer only public objects. They entered homes. Watches were created. Time became personal. Yet the direction never changed. Once a standard is widely accepted, changing it becomes almost impossible. A clock that moved the opposite way would feel wrong, confusing, and even broken. Not because it was incorrect, but because it violated expectation. By the time Europeans began traveling, trading, and colonizing other parts of the world, mechanical clocks traveled with them. The direction of time, decided centuries earlier by shadows in Europe, became a global standard. From that moment on, the world began to share not just hours and minutes, but a common direction for time. And all of it started with a simple decision: follow the shadow. And that takes us to our third segment, when direction became a rule. Once mechanical clocks became common, something subtle but powerful happened. The direction of the clock stopped being a practical choice and became a rule. People no longer thought about why the hands moved the way they did. They simply accepted that this was how time worked. The movement from left to right around a circle became so familiar that it felt natural, even inevitable. This is how conventions are born. A convention is not a law of nature. It is an agreement that forms through repetition. When enough people follow the same pattern for long enough, that pattern begins to feel correct. Clockwise is one of the strongest conventions in human history. As clocks spread through daily life, the direction of their movement began to influence other areas of society. Language was the first to change. People started using the clock as a reference point for direction. Instructions no longer needed long explanations. Saying, "turn it clockwise," was enough. Everyone understood what that meant. Gradually, clockwise became more than a description. It became a standard. This standard moved far beyond timekeeping. In engineering and mechanics, screws, bolts, and knobs were designed to tighten in a clockwise direction. This was not required by physics. It was chosen because it matched what people already expected. Turning right felt like moving forward. Turning left felt like reversing. In printing and graphic design, circular diagrams follow the same movement. Later, when screens and digital interfaces appeared, designers continued to use clockwise motion for progress, loading, and rotation. Even when there were no physical gears involved, the visual language remained the same. The clock had trained the eye. By the 19th and 20th centuries, the idea of clockwise was so deeply embedded that it no longer felt connected to clocks at all. It became a general concept of order and direction. What is especially interesting is that this convention spread globally, even to places where the original sundial experience was different. Societies in the southern hemisphere adopted the same clockwise standard, despite the fact that the sun's shadow there moves in the opposite direction. This shows how cultural influence can override geography. European technology, trade, and education systems carried clocks and their direction around the world. Over time, this imported standard replaced local variations. A single way of representing the time became global. As a result, clockwise is now understood almost everywhere, regardless of latitude, climate, or culture. This moment marks an important transition in the story. Time was no longer guided by nature. It was guided by habit. The shadow had disappeared, the gears were hidden inside machines, and the original reason for the direction was forgotten. Yet the movement continued unchanged. Clockwise had become invisible. And when a convention becomes invisible, it becomes powerful. And that takes us to our fourth segment, clockwise in a digital world. By the late 20th century, timekeeping no longer depended on gears, springs, or weights. Clocks became electronic. Watches used quartz crystals. Phones, computers, and satellites measured time with extraordinary precision. The physical movement of hands was no longer necessary. And yet, something surprising happened. Clockwise did not disappear. Even as digital displays replaced analog clock faces, the old direction remained deeply embedded in design and behavior. When people interacted with new technology, they continued to expect movement in the same familiar direction. Digital clocks often removed the hands, but they did not remove the idea of rotation. Progress indicators, loading circles like the one we have in the picture, and animated icons usually move clockwise. Volume controls, dials in software, and virtual knobs still turn the same way mechanical ones did centuries earlier. This is not because computers need it. It is because humans do. Designers understand that technology feels easier to use when it follows existing mental models. A mental model is the internal picture people have of how something should work. For time and rotation, that picture was created long ago by clocks. Changing the direction would not improve performance. It would only create confusion. So even in a world of code and pixels, designers continue to respect a rule invented by shadows on stone. This continuity shows how deeply history influences modern life. Technology may evolve quickly, but human expectations change slowly. There is also a psychological dimension to this. For many people, clockwise feels like progress. It feels like moving forward, completing a cycle, or reaching a goal. Counterclockwise, by contrast, often feels like undoing, reversing, or going backwards. These associations are learned, not natural, but once learned, they are powerful. Because of this, clockwise motion is often used in countdown animations, timers, rotating indicators that show activity or success. The direction communicates meaning without words. What is remarkable is that none of this was planned. No global organization decided that clockwise would represent progress in the digital age. It happened naturally because millions of people already shared the same visual language. The clock had become a cultural reference point. At this stage in the story, the original connection to the sun is completely invisible. Most people have never used a sundial. Many have never even seen one. Yet, the direction established by sundials still shapes how we experience time on our phones and computers. The past is still present, quietly guiding our expectations. Clockwise survived not because it was necessary, but because it was familiar. And familiarity in human culture is often stronger than logic. And that takes us to our segment 5. Could time have gone the other way? At this point in the story, it becomes clear that clockwise was not inevitable. Nothing in the laws of physics demands that time be drawn in a circle moving from left to right. The universe does not care which way the hands of a clock turn. Atoms vibrate, planets move, and energy changes direction without consulting a clock face. The direction we use to represent time is a human decision. If early mechanical clocks had been developed in the southern hemisphere, The global standard might be completely different. People might feel comfortable turning knobs counterclockwise to move forward. Digital progress indicators might spin the opposite way. The word clockwise itself might not even exist. This realization invites a simple but powerful thought experiment. Imagine encountering a clock for the first time with no prior experience. There would be no obvious reasons to prefer one direction over the other. But both would be equally logical. Meaning would only appear after repetition. This shows how deeply human understanding depends on habit. Once a system is learned early and reinforced constantly, it stops feeling like a choice. It feels like reality. Clockwise is a perfect example of this process. What began as a local observation became a global assumption. The same pattern appears in many areas of life. Reading direction. We read from left to right. Maps and orientation. Measurement systems. Even musical notation. These systems work not because they are universal truths, but because societies agree to use them. Timekeeping is not different. Excuse me. When we say time moves forward, we are using a metaphor shaped by culture. The arrow of time in physics describes entropy, not clock hands. The clock face is a symbolic tool, not a natural phenomenon. And yet, symbols matter. They shape how we think, how we explain the world, and how we teach future generations. The circular motion of the clock gives time a visual form. It suggests cycles, repetition, and return. These ideas influence how we experience daily life, schedules, and routines. In this sense, clocks do more than measure time. They interpret time. Understanding that the direction of a clock is a human invention does not make clocks less useful. Instead, it makes them more interesting. It reveals them as cultural objects, designed, inherited, and maintained across centuries. Time continues to move forward, but the way we draw it is a story we tell ourselves. And like all good stories, it could have been written differently. Okay, and let's go to our context of vocabulary in context. Before we close today's episode, let's take a moment to revisit some of the key words and ideas that shaped this story. Understanding these terms helps connect language with meaning and history with everyday use. Okay, so our first word, clockwise. This word describes movement in the same direction as the hands of a traditional clock. It has become a global reference for rotation and direction, even in situations that have nothing to do with time. When we say something turns clockwise, we are relying on a shared cultural image. Our second word, the opposite, counterclockwise, also called anti-clockwise in British English. It describes a circular movement that goes in the opposite direction of a clock's hands. Okay, so don't forget that if you have a bottle, for example, yes, closing the bottle clockwise, opening the bottle counterclockwise. Okay, our next word, sundial. A sundial is one of the oldest timekeeping devices in human history. It uses the position of the sun and the shadow of a fixed object to indicate the time of day. Sundials remind us that early measurements of time were based directly on natural observation. Next word, hemisphere. A hemisphere is half of the Earth. The planet is divided into the northern and southern hemispheres by the equator. This distinction matters in timekeeping history because the movement of the sun, and therefore shadows, differs depending on the hemisphere. Next word, convention. A convention is a rule or practice that people follow because it is familiar and widely accepted, not because it is required by nature or science. The direction of clocks is a clear example of a convention that became invisible through repetition. Next, and our last word, mechanism. A mechanism is the system of parts inside a machine that makes it work. In early clocks, mechanisms replaced the sun as the driver of time, but they kept the same direction that people already understood. These words are not just technical terms. They help explain how human choices, geography, and habit combine to shape something as universal as time. And that takes us to our closing reflection, the silent agreement. The clock on the wall does not argue with us. It does not explain itself. It simply moves. Yet, behind that quiet movement is a long human story, one that begins with sunlight and shadows, passes through medieval towers and turning gears, and continues today on glowing screens. Clocks run clockwise not because they must, but because we agreed that they should. That agreement has survived centuries of technological change. It has crossed borders, oceans, and cultures. It has become so natural that we no longer notice it. And that is the true power of convention. Time continues whether we measure it or not. But the way we see time, the direction we draw it, the movement we expect, is a reflection of human history. Every glance at a clock is a quiet reminder that the past is still with us, shaping the present in ways we rarely stop to see. And sometimes all it takes to uncover that history is to ask why something turns the way it does. Okay, that's it. Thank you so much for spending this time with me on Tune In and Speak Up, the podcast from Universidad Militar Nueva Granada. I hope you enjoyed our journey answering the question, why do clocks run clockwise? And discovered how even the most ordinary objects can carry deep cultural meaning. If this episode helped you see everyday life a little differently, or helped you connect language with history and culture in a new way, then this episode has done exactly what it was meant to do. Learning English is not only about grammar or vocabulary. It is also about understanding how people live, think, and express values through simple actions. This season, we will continue exploring unusual yet meaningful topics that reveal the strong connection between language, history, and daily experience. Each episode is designed to help you improve your listening skills, expand your vocabulary, and develop a deeper awareness of how culture shapes communication. If you found today's episode useful or interesting, feel free to share it with your classmates, friends, or fellow English learners. Learning becomes stronger when it is shared, discussed, and experienced together. And if you'd like to share your thoughts, reflections, or feedback, we would truly love to hear from you. Your ideas help us grow, and your voice helps shape future episodes. This podcast exists for learners like you, curious, thoughtful, and committed to improving step by step. We'll be back next week with another topic that may surprise you, make you reflect, or inspire new conversations in English. Until then, keep listening, keep practicing, and most importantly, keep exploring the world through language. And as always, keep speaking up. Until next time. Leonardo, thank you very much. See you next week with a new and interesting story. Thank you.
Desde la Universidad Militar Nueva Granada, en Bogotá, Colombia, transmite UMNG Radio. UMNG Radio. Una emisora alternativa, cultural e independiente. Desde la Universidad Militar Nueva Granada. Esta es UMNG Radio.